Hi guys, welcome to another video, and this is the last video on angle at the center is twice the angle at the circumference. So we are investigating when the angle at the circumference is an obtuse angle now. So remember, we've discovered that if the angle at the circumference is the above the chord now, then it means it's going to become an acute angle, and the angle at the center is going to be the gray um, angle. And then if the angle at the circumference is below the chord, it's going to be an obtuse angle. Then the angle at the center will be the pink angle over there, because D is comprised of an, an obtuse a revolution, which is 360. So we've investigated that because the angle breaks when or the relationship of angle at the center is twice the angle at the circumference breaks when the angle is an obtuse, which is now 119.12 degrees. It's no longer twice the angle at the circumference. But if now we say 360 minus the angle at the center, now we get that the relationship is that the angle at the circumference has now formed a relationship with the angle above the gray angle there. It's no longer with the one that is gray. It has an angle. It has an angle relationship with the one that is pink. So now, how do we prove that? We are still constructing. So what do I do? I join C and D and produce to E, so that I can create an exterior angle. So I'm going to separate my angle D into D1 and D2. So now I have two triangles here. The first triangle is triangle DBC. Yes, DBC. And the second triangle is the blue triangle, which is DAC. So now I know that D1 is the exterior angle of the blue triangle, which is triangle DAC, and the exterior angle of a triangle is equal to the interior opposite. So what I'll do here, it's equal to the sum of the interior angle. What I'll do here, I'll label this C1 and C2. So now, because the exterior angle of a triangle is equal to the sum of the interior opposite, it means that D1 is equal to C1 plus A, and that is exterior angle of a triangle is equal to the sum of the interior opposite. But now we have that AD is equal to DC because they are radii. AD is equal to DC, and because they are radii. Then now it means that C1 is equal to A because their angles opposite equal sides. So therefore D1 is equal to C1 and A is equal to C1, so it's C1 plus C1 is twice of C1, and that is in triangle ADC. And then in triangle BDC, so here's BDC, we have that D2 is equal to C2 plus B, and that is the exterior angle of a triangle. This exterior angle of a triangle is equal to the sum of the interior opposite. And also DC is equal to DB, and that is because they are radii. Therefore C2 is equal to B, but we've said that D2 is equal to C2 plus B, but B is equal to C2, so it's gonna be C2 plus C2, which is 2 times C2. And then now we can create this whole angle as what? As D1 plus D2, and we said D1 is equal to twice of C1 plus, and then D2 we said is equal to twice of C2, which is equal to 2 times C1 plus C2 is the angle at the circumference. Therefore, the angle at the center is twice the angle at the circumference. So I did enjoy proving these theorems with you, and there's many more to come. And do like, comment, and subscribe. I would appreciate your input and how you are feeling the session, and how can I improve my engagement with you. Now I'll see you on the next video when we are proving the next theorem.